All right, welcome back. Today, we're going to demystify a really clever AI strategy for learning more efficiently. It's called N-step off-policy learning, and trust me, it solves a super interesting puzzle that's right at the heart of how AI gets smart. So, let's just jump right into the big question. Imagine this. You want to figure out the absolute fastest, most perfect way to get home from work. But, some days you don't take that perfect route. Maybe you take a scenic detour, you stop for coffee, or you check out a new store you've been meaning to visit. So the real puzzle is, how can you still learn about that perfect route while you're out there taking all these interesting but technically imperfect detours? That's the exact problem we're going to tackle today.
So this whole method was basically invented to solve what we can call the learning dilemma, which is really two big puzzles that every AI has to face when it's learning.
Okay, so puzzle number one is this classic tug-of-war between learning speed and accuracy. On one side, you've got something called one-step TD learning. Think of it like a student who's in a huge rush. They learn fast because they update their notes after every single thing they see. But the catch is, they're basically guessing based on other guesses. It's quick, but it can be kind of shaky. Then, on the other side, you have Monte Carlo learning. This is the super patient student. They wait until the entire lesson is over to see the final grade before they learn anything. It's incredibly accurate, right? But man, is it slow. So the big question is, can we find a happy medium?
And the second puzzle, this is a big one. It's called the explorer's dilemma. It's this constant battle between exploration and exploitation. Think about it. To get a good result or a big reward, an AI needs to exploit what it already knows works. Stick to the tried and true path. But to find the absolute best path, it has to explore new things, right? Try out stuff it's never done before. It's a real catch-22. If you only exploit, you might get stuck in a rut that's good, but not great. And if you only explore, you're just wandering around and never actually getting anything done. It is a constant balancing act.
Okay, so how do we solve these two dilemmas? Well, to make this all super intuitive, we're going to use a simple road trip analogy. I promise, this is where everything is going to click into place.
So first, let's define our terms using this road trip. We have what's called the behavior policy. Super simple. This is the route you're actually driving. It's your scenic route with all the spontaneous detours for coffee, sightseeing, whatever. This is the policy that's out there in the real world, doing things and gathering experiences.
And then we have the target policy. This is the complete opposite. This is that perfect, optimal route your GPS spits out. The most efficient path. No messing around. It's the route you want to learn about, but you aren't actually following it. And that right there is the key idea. We've got one policy for doing, the behavior policy, and another one for learning about, the target policy.
So, now we can rephrase our big question using this analogy. How can the driver learn about the perfect GPS route, that's our target policy, while they're actually driving their own scenic route, the behavior policy? How do you learn about path A while you're on path B?
Okay, so how do we pull this off? Well, the solution is actually a combination of three key ingredients. Let's break them down one by one.
First up, we've got N-step learning. And this is our answer to that whole speed versus accuracy problem. Remember the hasty student versus the patient one? This is the middle ground. Instead of updating your knowledge after just one step, or waiting for the entire trip to finish, you look ahead N steps. Maybe that's 5 towns down the road. It's a much more balanced and stable way to update what you know.
The second ingredient is off-policy learning. And really, this is the whole heart of the idea. It's what allows us to learn about our target policy, that perfect GPS route, using the experiences we get from following our behavior policy, our scenic drive. It totally separates the act of learning from the act of, acting. And just like that, it solves our explorer's dilemma. We can explore all we want and still learn about the optimal path. But wait, you might be thinking, how does that actually work? How can you learn from a detour that the perfect route would never take? Well, that brings us to our third ingredient, the real secret sauce, importance sampling. Now, this sounds fancy, but think of it as a clever correction factor. It's the mathematical magic that connects our two different routes. It basically looks at something you did on your scenic drive and asks a simple question: what are the odds that the perfect GPS route would have done the exact same thing? And based on that, it assigns a weight to that experience.
So, for example, let's say after all that math, the importance sampling calculation spits out a number. Let's say 0.7. Okay, so what in the world does that mean?
It's actually pretty simple. It means we only trust the lesson from that experience about 70%. So, if you take some wild detour for a weird tourist trap that the perfect GPS route would never in a million years recommend, that experience gets a really low weight, maybe close to 0.
But if you take a turn that the GPS route also would have taken, that experience gets a weight of 1, or, 100% trust. It's a brilliant way to filter your experiences and decide which ones are actually useful for learning about that perfect path.
All right, let's put it all together now. We've got our 3 key ingredients: end-step learning, off-policy learning, and that all-important correction factor, importance sampling. Let's see how they work together in a nice, clean learning loop.
Okay, so here's how the whole process plays out. Step 1. Drive. The agent follows its exploratory behavior policy, our scenic route, for a certain number of steps, let's say n steps. Step 2. Look back. It takes a look at that little chunk of the trip and sees what happened, what rewards it got, where it ended up. Now for the most important part, Step 3. Correct. This is where it applies that importance sampling ratio, mathematically correcting for any detours that the optimal policy, the GPS, would not have taken. And finally, Step 4. Update. It takes this newly corrected weighted experience and uses that to update its knowledge of the perfect target policy. And then, it just does it all over again. It's a continuous loop, getting a little bit smarter about the perfect route with every single batch of n steps it takes.
Whew, okay, we've covered a lot of ground. So if there's just one single thing I want you to walk away with, one key takeaway from all of this, it's this right here.
9-step off-policy learning allows an agent to learn about the perfect path by wisely correcting the lessons learned from its own imperfect detours. It's really about being an explorer, but learning like an expert.
And it's a really powerful idea that goes way beyond just AI. It kind of makes you wonder, right? Where else in our own lives could we learn valuable lessons by taking the scenic route? Something to think about. Thanks for tuning in, and I'll catch you on the next one.